All right, here we go. Our next section. This one's going to be on hyperbolas. And a hyperbola is very similar to an ellipse as far as its equation is concerned here, with the major difference being that instead of adding these two fractions together like we were before, and now we're going to be subtracting them. And that's going to be the change from an ellipse to a hyperbola. And um, let's go ahead and play around with them a little bit. So a horizontal hyperbola, so if it's going to be opening uh, to the kind of towards its x-axis, um, here's a rough sketch of um, a horizontal hyperbola. And notice that it's opening to negative x, it's opening to positive x, not to y. And so always, whatever the positive fraction is of the two, that's the direction that it's going to be opening. So then probably tell that over here with our y being positive, that this one's going to open upward and downward. Again, these are just really rough sketches of what's going on, but when x is positive, we have this situation, and when y is positive, we have this situation over here. Now, how can we, let's kind of find out some more things about it. So our center, just like with the ellipse, is still going to be at HK. So our center is at HK. So right here, it looks like our center is at 0, 0. So we would have x minus 0 squared. It's really just x squared divided by a squared, and we'll talk about that one in a moment. And then y minus k, which would be 0 if it's at the center, so y squared divided by b squared. And again, it's minus here. That's the big kind of Q in that we need to see here. And so let's find some more pieces. We're still going to have vertices here on our hyperbolas where it's farthest point, it's maximum or minimum, and depending on how you want to, depending on what's going on right there. So let's, yeah, again, kind of continue. How would you find out where these vertices are at? Well, you're going to take your a and b values and take the square root of it. It's just going to be at a and b added and subtracted from the center. So for right here, this point would be at, since we said our center was going to be at 0, 0, our point right here, our vertex right here, would be at 0 minus a, so negative a, comma 0. Over here would be at 0 plus a, so positive a, comma 0. Though we won't have it, and this piece I'm about to draw isn't actually part of the hyperbola, but just something to help us sketch it. If it were to be opening to the y direction, where would those vertices be? Well, they'd be at b. So 0 plus b, 0 minus b. And these points, again, they're not actually part of our graph, but they're going to be really useful to us. So this would be at b comma 0. This would be at 0 minus b, so negative b comma 0. And what we're going to use those for is to kind of sketch this little box. And I want to say it one more time, this is not part of the graph. This is just a tool that we use to help us out. And so if I were to extend a line vertically here through negative a and a point through positive a, and same thing going horizontally here, hopefully we can see that there's going to be this box that is formed by those 4 points, where the vertices are at on the hyperbola and where the vertices would be if the y value was open. Same thing over here, we would have the actual vertices of the hyperbola, and then off to the left and to the right, so the center plus b and the center minus b, so this one will be b 0 as well, and this will be negative b 0. The box that is formed by these is kind of what will be a very useful tool for us in sketching our hyperbolas. All right. that will tell us where our vertices are at. First off, getting those pieces of the box. And we're going to have some asymptotes, or I can never pronounce that word, asymptotes that go through the diagonals of this box. And so let me use green for this one. They're going to go through the diagonals of this box. And what's going to happen with these asymptotes is that the hyperbola will approach, and so my sketch is going to be a little bit off there because it's not really approaching at the end, but it's going to get closer and closer and closer to the asymptotes as it continues on in either direction. It never will actually touch it. It just gets closer and closer and closer without touching it. And so kind of to re-sketch these pieces, now it's going to just get closer and closer and closer and closer and closer and closer. So they're not curved like a parabola. They get kind of straight the farther out you go. They're going to get closer and closer to that line, that green line there. All right. And now how do we know what the slopes of those lines are? And love it if you would just pause the video for a second and try to think about how would I know what the slopes of those are, because I think you'd be able to reason it through pretty well on your own. So hopefully you've paused it and thought about it. And well, from the center, however you want to think about it, if it's actually at the origin or wherever it is at, you would have to rise this the y value if it's b where the x fraction is positive, or if it's a where the y fraction is positive, but it's got to rise that amount. So it's going to rise either b and then run a, or if it's over here, it'll rise a and run b. But really, I wouldn't focus so much on b or a and trying to memorize that, but it's going to rise however much it's going with the y fraction. Oops, the y fraction, because that's where that's rise. We're looking for rise over run. That's how you find slope. And then it's, again, running x. So whatever the x denominator is, the square root of it, just the a or b value there. And that's going to be your one heading kind of up and to the right. And the other one will be negative that. So negative b to the right a. So negative b over a will be your other asymptote. We'll keep on looking at these a little bit more as we go along, but there's kind of just a fundamental idea of what's going on here. Some kind of key things I want to just say this again before we go, that the positive fraction, the one that's starting it, it determines whether it's opening horizontally or opening vertically, so keep that in mind. And the vertices are the square root of our denominator, and then we'll call them kind of the would-be vertices are the ones underneath your subtracted denominator, your negative denominator. Oh, we didn't talk about our foci. Let's talk about our foci for a moment. So just like with the ellipse, with an ellipse that we had that foci that was inside. So kind of we had a foci here and here, and that we're going to have our foci. They're going to be just kind of inside of the hyperbola, but the hyperbola is kind of, it's opening. There's two pieces of it opening away from each other, and so the foci will be inside those portions of the hyperbola. Now, how would we find them? And it's actually pretty much the exact same process as with the ellipse. It's going to be our shorter pieces squared equals our longest piece squared. And now if we were to take a look at this, our our biggest piece will always be from the center to the focus, to the foci. That'll be our c squared. So distance to focus squared is equal to the distance to the vertices, so distance to vertex squared, plus the, kind of run out of room here, but the distance to the would-be vertex. So the value here. So to find that, we would have our, well, a squared, our distance from the center to the vertex squared, plus our distance to the not vertex squared is equal to the distance from the center to the focus squared. Any last pieces we need to talk about? Just the very last piece here. This probably makes sense, but let's kind of be explicit about it as well. That once we know our slope, we talked about how to find that. To know what the equation of that asymptote line is going to be, well, we're going to have put it into point slope form. So it's going through, whether it's the positive or negative asymptote, that it's going to go through the center. So that's our point in the point slope form. So we'll have y minus the y value center equals plus or minus the slope, because remember there's one going positive and there's one going negative of the slope, and then that times the x minus the x value of the center. All right, a lot of information there, but hope that helps. All right.